I'm Mr. Train and this is Mr. Jones. We're teaching Year 4s. Our curriculum links are the natural and processed materials have a range of physical properties that can influence their use. And so today the prior knowledge of the students are that we've done molecular density in class before, so they're going in with a pretty good knowledge of it and they know a lot of adjectives and words to describe what they're seeing in their observations. And so today we're going to be doing the 4-level liquid experiment, and we're going to be moving through and helping them as they collaborate with one another throughout the experiment.
Our walk for today, we are going to be learning how different densities affect how molecules and atoms react to one another using 4 separate densified liquids, which will hopefully visualise how densities fit and affect each other when we get to our little activity.
Beautiful. So first of all, we've got the 4 liquids we have is honey, dishwashing liquid, water and oil, which is illustrated back here so the students know. And what we're going to do, first of all, so I want you guys to have a bit of a play with that and write down, collaborate. What do you notice about it? Observe it. What do you think?
Tell us about the honey's density?
It's thick.
Quite thick, isn't it?
Yeah, moves slowly.
Yeah.
And so what does that tell you about the atoms? Are they close together or far apart?
Close together.
Yeah, beautiful, awesome.
Yep.
Dishwashing liquid next.
Yeah, what do you reckon about the dishwashing liquid? What can you tell us?
Can move around a lot easier than the honey.
Still pretty thick though.
It's still,
Still quite thick, yeah.
It's not quite water.
Yeah.
Yeah.
Beautiful. Yeah. And then we've got water here, which we've coloured red for you.
Yeah. So easy.
This is free flowing.
Yeah.
And so what can you tell us about the atoms? Are they close together or far apart in this?
Further apart.
Further apart.
Why is that? Why do you think that?
Because it's less dense, so it's not compacted.
That's right.
Yeah.
That's right.
Awesome. Yep. And the last one we have here is oil. What can you tell us about that one?
It's free moving, but it's like sort of like it's got like that slime.
Yeah. So it's moving quite quickly and stuff.
Yeah.
Yeah. Awesome. So we've just quickly write up a few of the adjectives that we've got from the students. So in order, what order do you think these would go in density through what your observations have? So you've got thick, slow, sticky for honey, dishwashing liquid, you said it's slightly thick, oil, slimy and it moves quite quick in the cup, and the water is free moving. So if I was to say for you to put these in order of how dense you think they are, what would you do? Talk amongst yourselves, what do you think?
You would have to say honey.
Honey's got to go at the top.
Yeah.
Then
I think water will be at the end.
water's at the end, yeah. And then it's just determining which one's thicker out of these two.
Yeah, I would say
Dishwashing liquid?
dishwashing. Yeah.
So we've gone with honey, dishwashing liquid, oil and water.
Yeah.
You want to chuck it up for their prediction?
Will be honey, dishwashing liquid, oil and water, is that right?
That's correct.
Dishwashing liquid, oil, water. So, onto the activity. Have we covered everything? I think so. So, our activity that we'll be doing is using your prediction. We are going to put these liquids together into this glass and observe how the different densities affect one another. What some of our predictions, what's going to happen if we put these 4 liquids in at the same time. So all of a sudden, bang, all in at once, what do you think would happen?
Honey goes to the bottom.
Honey would go to the bottom. Would that be quick or would it take time?
Take time.
Depends if you pour it down the jar or go straight down the middle.
Side. Good observation. So the way that we're going to do this to avoid that is to do them one at a time, slowly. So first of all, we'll use the honey first, since we've gone the most dense. So I've given you a spoon and the honey to try to get it out and slide it down the bottom. Adam, you can do that one first.
All of it?
All of it.
And so do you still think that these are the describing words you'd use as you pour it into the cup, Joel? So is it quite thick, slow and sticky.
It was going pretty quick, pouring out. So it made the appearance look thick.
Yep.
But when it was actually like when Adam's pouring it in now, it goes quite quick into the glass.
Good answer. Very good answer. So next, what did we have next?
Dishwashing liquid.
Jonesy, can you fill that one in?
So how do I?
So just slightly slant the cup
Slightly.
when you pour it, and then just slide it down the side of it.
Quite slowly so they don't interact too quickly with each other. And straighten her out. Perfect. So do we have any interactions yet?
So
Have
what can
they-
you see?
There's
What's happening to them?
sitting on top of each other
Yeah. Why do you think that is?
because the honey's very thick and the dishwashing
More dense.
can't go through.
Can't get through. So
Beautiful.
it's simply sitting on the top. Very good answer. What is our next liquid that we're going to put in? So you select.
Oil.
You think the oil is going to be next?
Yep.
Give it a go. Same technique. Nice and slow down the side. Perfect.
So what's happened now? What
What's
can you
happened
see?
with our oil?
Oil now sits on top of the dishwashing liquid.
Yeah. So we know that it's
Not as dense.
beautiful.
First dense out of all of our liquids so far.
And the last one,
Which is our coloured water.
just slide it down. Yeah.
Perfect.
Beautiful. So what can you
interesting?
Yeah. What can you observe? What's happened?
They all stayed in shape. They all stayed in the layers that we poured them in.
Yeah, you can definitely tell where honey is.
Honey's down the bottom. What did we have next?
Dishwashing, you sort of, it's there, but it's sort of with the mercury sort of colour.
Yep.
Um,
What happened to the oil? Did the oil stay where it was, or did that move
Yeah,
when it reacted?
I reckon the oil has moved, yeah.
So where's the oil sitting now?
Half between the dishwashing liquid, I reckon.
Yeah. So has it come up or has it come down?
So when you added the water, where did the oil go? Did the water finish on top, or is that oil on the top? Have a look on the top.
What can you tell us? So is that oil or water?
Can't
Do you
both.
think?
Actually, yeah, well, the bubbles maybe
From the
but,
dishwashing.
yeah, maybe from
We've
there,
got the dishwashing liquid.
or from the oil.
The oil's on the top, I'd say. We've got the
Yeah, so
water.
see how it's clear. If you look at the side, it's nice and clear. And then we've got our red water here, and then we've got our green dishwashing liquid, and then our brown honey. So with that, so see now, what can you tell us about maybe the oil and the water? Which one do you think now is less dense? Oil?
Yeah.
Yep. Why is that? Why do you
Because
think?
it's clear.
Yeah.
Yeah.
And
It's got like a. Well,
Where's it in the cup?
where's it in the cup now?
up the top?
Yeah. So we can say that it's more dense or less dense than water.
Less dense.
Beautiful.
Perfect.
So the order that we should have done it in is honey, you got that correct? Dishwashing liquid, beautiful. And then we'd switch these two around, hey?
That's right, yeah.
Beautiful, because we now know that oil's less dense.
Yep.
Beautiful.
So our prediction was very close.
Yep.
Only slightly off. A good way to remember it, relating it to our topics, the oil spill that happened in the US when the big BP oil mine, all the birds and oil came to the surface, a lot of wildlife died. That's how I remember that water and oil
Absolutely.
is different densities.
So going back to our wall, we can see we're learning how different densities affect how molecules and atoms react to each other. And as you guys were explaining, that you know that the honey's, the molecules and the atoms of it are quite closely packed towards each other. So it's more dense, it's going to sit at the bottom. And dishwashing liquid comes up, it's not as dense, but it's still pretty dense. And then same, we've got water and then oil as well. Oil's quite free flowing, so it's really less, it's not as dense and it sits on top. So what would happen if we were, say, to turn this whole cup upside down? What would you think would happen?
They'll keep it shape.
Yeah. So we'd then have the honey at top, and then the dishwashing liquid, and then the water, then the oil, and then it would just, you reckon, it just flip back to this order here?
If you left it for, let's say, an hour,
Yep. What would you
would it
think?
find its way
Yeah,
back into this?
because the weight of
Yeah.
density will go
Yep.
to the bottom, yeah.
Beautiful.
and move it down?
Good job.
Perfect.